morning.
Good morning, sir.
Good.
How are you? Yes. How you are studying? Reading or not? Good morning, dear students.
Good morning, sir.
Okay. Today topic is small intestine. Today topic is small intestine. This is the location of the small intestine in the abdominal cavity. It is located in the abdominal cavity below the stomach. It is a small intestine is a part of gastrointestinal tract, GIT. It is a part of GIT, that is gastrointestinal tract. It is a tubular structure. This is the location of the small intestine. This is the exact location, which is continuation of the pyloric part of the stomach continues as a small intestine. Coming to the introduction, small intestine, as I told, it is a part of GIT, which extends from the pyloric part of the stomach to the ileocecal junction. The intestine, which is the small intestine, which is the longest part of the digestive tube, and it is divided into two parts: small intestine and large intestine. Following. Hello. Hello.
Yes, sir.
Intestine is divided into small intestine and a large intestine. The main function of the small intestine, food has to it is the main function is the digestion, metabolized and stored for the expulsion of the in the intestine. The main function of small intestine is absorption of the food. Now, coming to the proper small intestine, as I told, it is extends from the pyloric part of the stomach to the ileocecal junction. So, small intestine extends from the pylorus of the stomach to the ileocecal junction. It is about 6 meters long. The length of the small intestine is 6 meters, whereas the length of the large intestine is 1.5 meters. Remember this. Length of the large intestine is 1.5 meters, whereas length of the small intestine is 6 meters. The approximate 2.5 to 3 it is the diameter. Diameter is 2.5 to 3 centimeters in diameter. The surface area of human small intestine mucosa averages 30 square meters because it is an organ of absorption. Small intestine is an organ of absorption. Hence, it requires large surface area. The length is greater in males than in females. The length of the small intestine is greater in males than in females. As it is the main function is absorption. So it requires large surface area for the absorption. It receives the bile juice. The intestine receives the chyme from the stomach. It also receives the bile juice and pancreatic juice through the pancreatic duct, controlled by the sphincter of body. Ileocecal sphincter transition between the small and the large intestine. Coming to some aspects of histology of the small intestine. As you know, GIT consists of 4 layers. There is a mucosa, submucosa, muscular section, and a serosa. These are the 4 layers of the GIT. So this small intestine is meant for increase. It is meant for absorption, and it requires a large surface area. Large surface area is achieved by following things. One is the great length of the intestine. As I told, it is 6 meters. The length of the intestine. There is a circular folds within the mucosa. Those are called as the plicae transverse, or it is walls of Kerfling. These folds of the intestine lining. Second comes the villi. Villi are these walls of Kerfling are the permanent folds. These are they present permanently. They not disappear on distinction of the small intestine. So second point is villi. There is a finger-like projection of the mucosa. The mucosa of the small intestine projects like a finger-like projection. Those are called villi. These villi also increase surface area for absorption. Second is the lacteus. Terminal lymphatics in the villus. Villi consists of a lymphatic chain or lymphatic vessel and intestinal glands lined by enteroendocrine, goblet and stem cells. There are in between the basis of the villi. There is the glands. Those are called as the intestinal glands. These glands are lined by enteroendocrine and enteroendocrine cells, goblet cells and stem cells. There is a duodenal gland in the initial part of the duodenum, which produces mucus, purpose and urogastrum. Now, this small intestine is divided into parts. As it is 6 meters, the proximal part of the intestine is the most fixed part. It is the widest and most dilated part. That part is called as the duodenum. It is called as the duodenum. You can see in this image. There is a colored area that is called duodenum. That is the retroperitoneal organ and most widest and fixed part of the small intestine. Remaining part of the small intestine is having some mobility. That is called the second remaining part is called as the jejunum and ileum. So these are the parts of the small intestine. Same. The small intestine is divided into 3 parts. The proximal part after the pylorus up to duodenal structure is called as the duodenum. As I told you, it is the retroperitoneal and most fixed part of the small intestine. It is present in the form of C-shape, curved around the head of the pancreas. Remaining part of the small intestine, which is mobile. The proximal 250 is the jejunum and remaining part is called as the ileum. As such, there is no clear-cut distinct differentiation between jejunum and ileum. You can see here the parts of the small intestine. Mixing bowl acid, duodenum, stomach ends in pylorus. The pylorus part continues the most dilated part, that is the duodenum. Which duodenum measures 25 centimeters in length. After that, there are piles. Those are called piles of jejunum and piles of the ileum. So this ileum ends at the ileocecal junction and then continues as the cecum or the large intestine. Coming to the first part of the small intestine, that is the duodenum. Duodenum is a very important, and you will have a long question on duodenum. Describe the second part of the duodenum or entire duodenum along with the relations you have to describe. As I told, duodenum is a Greek word which means 12 fingers. Duodenum is the shortest structure, about 20 to 25 centimeters long, contains with the stomach and shaped like a C. This duodenum lies above the level of umbilicus. It lies above the level of umbilicus, opposite the first, second, and third lumbar vertebra. It surrounds the head of the pancreas. Understand? The duodenum is the most dilated fixed part of the small intestine, which is present in a form of C around the head of the pancreas. It is the continuation of pyloric part of the stomach. It is the continuation of the pyloric part of the stomach. And where it forms a C-shaped curve around in the concavity of the C, there is a presence of head of the pancreas. And this duodenum is present above the level of umbilicus, opposite the first, second, and third lumbar vertebra. This duodenum receives gastric chant from the stomach. The food is converted along with the gastric juice and saliva. The food bolus is converted into soft bolus that is called as chant, together with the digestive juice from the pancreas. The pancreatic duct, main pancreatic duct opens into the second part of the duodenum, which we have forced the digestive enzymes, and there is the gallbladder, and also there is a gallbladder for the bile. So these are all the duodenum tissues. Digestive enzymes break down the proteins and bile and emulsify fats into small particles. Duodenum contains Brunner's gland, which produces mucus-rich alkaline secretion containing bicarbonate. Duodenum, stomach, as already know, stomach contains goblet cells. They also produce mucus. So, duodenum contains a gland. Those are called as the Brunner's gland. In the submucosa, there is a mucus secreting glands. Submucous layer contains the glands, which are mainly mucus secreting. So, those glands are called as the Brunner glands, which produce mucus-rich alkaline secretion containing bicarbonate. These secretions in combination with bicarbonate from the pancreas neutralizes the stomach acids contained in the gastric chant. This will see after. Now parts of the duodenum. This is the shape of the duodenum. This is the first part, this is the second part, third part, and fourth part. Total length of the duodenum is 25 centimeters. Remember, it is the retroperitoneal. Only proximal part of the duodenum is suspended by lesser omentum and greater omentum. The remaining part of the duodenum is fixed and retroperitoneal. It is the shortest, widest, and most fixed part of the small intestine. Hence, the duodenum is divided into four parts. The first part is called superior part, which measures 5 centimeters in length. This part is called as the superior part, which measures 5 centimeters in length. Second part is descends vertically downwards. That is called as the descending part, which measures 7.5 centimeters in length. Understand? First part is small. That is called as the superior part. Second is vertically descends by the side of the vertebral column. That is called as the descending part, which measures 7.5 centimeters. Third part, third part is called as the horizontal part, which is present around the third lumbar vertebra, which measures 10 centimeters in length. And the fourth part is called as ascending part, which measures 2.5 centimeters in length. The first part is 5 centimeters long. It is anterolateral to the body of first lumbar vertebra. It is the most movable part because it is suspended by lesser omentum and greater omentum. Hence, that part of the duodenum is more movable. Understand? First part, which is superior part, is 5 centimeters. It is anterolateral to the body of first lumbar vertebra. It is the most movable part. Second part, as I told, it measures 7.5 to 8 centimeters all long. It descends along the right side of the L1 through L3 vertebra. That is side by side of the vertebral column. So up to lower part of the L3, it descends vertically downwards. That part is called as the descending part. Third part is 10 centimeters long. It crosses the L3 vertebra. It traverses along the L3 vertebra. That is called as the horizontal part or third part. The fourth part is 2.5 centimeters long. It begins at left of the lumbar vertebra and rises superiorly as far as the superior border of the L2. So fourth part starts from the L3. It ascends upwards up to the lower part of L2 vertebra and continues with the jejunum. duodenum extends from the pylori to the duodenal flexure. From the duodenal flexure. The first part of the that is superior part continues from the pylorus to the superior duodenal flexure. Second part from the superior duodenal flexure to inferior duodenal flexure. Third part is the transverse, which extends from inferior duodenal flexure up to the lower part of the third lumbar vertebra. That fourth part continues from that to the ileocecal. So these are the various parts of the duodenum. In the concavity of the duodenum, there is the presence of the head of the pancreas. So first part of the duodenum, the function, the duodenum is developed partially from the foregut and midgut. It partially develops from the foregut and midgut. Hence, it is supplied by the arteries of both celiac artery as well as the superior mesenteric artery. So duodenum, the relations of the first part, anteriorly there is the quadrate lobe and bile duct. Posteriorly there is the presence of gallbladder. Anteriorly there is the presence of quadrate lobe and gallbladder. Posteriorly there is the presence of gastroduodenal artery and common bile duct. Posteriorly and superiorly there is the presence of epiphytic foramen. Inferiorly there is the presence of the head of the pancreas. So these are the various parts of the duodenum. Now coming to the blood supply of the duodenum. As I told you, duodenum is supplied developed from the foregut as well as the midgut. So the artery of first artery blood is superior pancreatic artery. Superior pancreatic artery is the branch from the gastroduodenal artery, which in turn is the branch of celiac artery, which in turn is the branch of the hepatic artery, which is in turn is the branch of celiac artery. So hence superior pancreatic duodenal artery is the branch from the foregut, that is celiac artery. Inferior pancreatic duodenal artery, it is a branch from the superior mesenteric artery. These are the two branches, superior and inferior pancreatic duodenal artery, the anastomosis, and forms of plexus are on the anterolateral and posterior superior part of the duodenum. So you remember superior pancreatic duodenal artery and inferior pancreatic duodenal artery. Apart from this, there is a supraduodenal artery of Wilkie. So this is special artery which supply only first part of the duodenum. Anterosuperior, posterior part of the duodenum. So this is again branch, say gastroduodenal artery from the celiac. Then the fourth artery is the retroduodenal artery. Again, it is a branch from the superior mesenteric artery. Venous drainage. The veins of the duodenum drain into splenic vein, superior mesenteric vein, and ultimately drains into portal vein. Splenic vein is formed by superior mesenteric vein, and portal vein is formed by superior mesenteric vein, and splenic vein joined to form the portal vein. So venous drainage of the duodenum drained by three veins. One is splenic vein, behind the spleen. Second one is superior mesenteric vein. These two veins join to form the portal. Coming to the next part of the small intestine, that is, as I told, jejunum and ileum. Jejunum and ileum is the most mobile part of the small intestine because they are suspended by a fold of peritoneum. That is what is the mesentery. Jejunum is the mid secretion of the small intestine, connecting the duodenum to the ileum. Mid part of the small intestine. Jejunum is the mid part of the small intestine, connecting between the duodenum and the ileum. As I told, jejunum and ileum are the most mobile because they are suspended by a fold of peritoneum. That is what is the mesentery. It is about 2.5 centimeters long and contains plica circularis and villi that increase the surface area. Products of digestion, sugars, amino acid, and fatty acids are absorbed into bloodstream here. The successor muscle of duodenum marks the division between the duodenum and the jejunum. Then coming to the ileum, the final secretion of the small intestine. It is about 3 meters long and contains villi similar to the jejunum. It absorbs mainly vitamin B12 and bile acids as well as any other remaining nutrients. The ileum joins to cecum of the large intestine at the ileocecal junction. Now, there are some differences between the jejunum and the ileum. There are some differences between the jejunum and the ileum. Characteristics. First one is jejunum and the second is ileum. Color deeper red. Jejunum is deeper red, whereas it is paler pink in color. Ileum is pink in color. As I told, there is no clear-cut demarcation between jejunum and ileum. As there is no clear-cut demarcation between jejunum and ileum, and you cannot able to differentiate between jejunum and ileum. Wall. The jejunum wall is thick and heavy. Wall of the jejunum is thick and heavy, whereas the wall of the ileum is thin and light. Wall of the ileum is thin and light. Vascularity. Jejunum is having a rich blood supply. Ileum is having a less blood supply. There is arcades. Arcades are nothing but loops of blood vessels. The main arteries are reaching the intestine. They divide into branches. These branches they anastomose and forms the arcade. So few large loops. Arcades are present. There are few large loops present in the walls of the jejunum, where many short loops are present in the ileum. Vasa recta is nothing but the arcades again gives rise to smaller minute branches which forms a network, plexus. That is what is the vasa recta. Vasa recta of jejunum is long, whereas the ileum is short. Fat in the mesentery is less. As I told, they both are suspended by fold of peritoneum. That is what is the mesentery. This mesentery contains fat, which is less in the jejunum and more in the ileum. Circular folds are large, tall, and closely packed. Those are called as the walls of Karpin. As I told, these are circular folds formed by the mucosa and submucosa. These are permanent folds. Hello? Hello? Anybody is listening or not?
Yes, sir.
Listening?
Yes, sir.
Mesentery is mainly the site of deposition of the fat. Fat in the mesentery is less in the jejunum, whereas more in the ileum. Circular folds are large. I told circular folds, those are walls of Karpin. These are circular folds which help to increase the surface area for the absorption, as well as also the slow stone, the contents passing the intestine. Because of these circular folds, the contents are slowly, it slows down the contents passing in the intestine. So these walls are called as the walls of Karpin, and these are permanent. They will not obliterate when the intestine distance. Lymphoid follicles are called as Pierce patches. You see the histology. There is the aggregation of lymphoid follicles. Aggregation, 2 or more than 4 to 5 lymph node join and forms a bigger lymphatic follicle. That is called as the Pierce patches. So there are very much few in jejunum and many in ileum. This is mesentery. Mesentery is nothing but a broad fan-shaped fold of peritoneum that suspends the jejunum and ileum from the posterior abdominal wall. Mesentery, as already known, folds of peritoneum of part is ligaments. Spleen is suspended from various ligaments. Like that, it is mesentery. Mesentery is nothing but a fold of peritoneum, which is the shape of this mesentery is fan-shaped, which suspends the piles of jejunum and ileum from the posterior abdominal wall. It also conveys nutrition and innervation to the intestine. It consists of 2 layers derived from the greater side. The mesentery consists of 2 layers. Both layers are derived from the greater side. Root mesentery consists of two parts. One is the root and second is pre-margin. Pre-margin is attached to the coils of the intestine. Pre-margin of the mesentery is attached to the coils of the intestine, whereas the root is attached to the across the posterior abdominal wall, which measures 15 cm long. Mesentery is having one is the root and another one is pre-bottom. The root is attached to posterior abdominal wall across the posterior abdominal wall, which measures 15 cm long. Extends from the left side of L1 vertebra. Left side of the L1 vertebra. This root extends, which measures only 15 cm length. Extends from the left side of the L1 vertebra at the deuterojejunal junction. Then this extends to right sacroiliac joint at ileocecal junction. That is the extension of the, and this mesentery is a short node. Mesentery is a short node. Either it may come in 5 months or 3 months. That time you have to describe everything. What are the attachments, everything you have to read. Next border is pre-border. As I told you, it separates and includes jejunum and ileum. So this is mesentery. This is the mesentery. Mesentery is nothing but it suspends the piles of jejunum and ileum from the posterior abdominal wall. This is mesentery. This is fold up anatomy. Both layers are formed from the greater sac. It suspends the piles of jejunum and ileum, and the jejunum and ileum are having maximum mobility. A maximum mobility, understand? So this is mesentery seen in the dissected specimens. This mesentery not only suspends the piles of jejunum and ileum, that is also path to provide nutrition to the jejunum and ileum. Now coming to the wall of the small children, already we have seen the 4 legs. We will see in detail. Wall of the small intestine is made up of following 4 legs. One is serous cord, second one is muscular cord, third is submucosa and mucous cord. This is from outside to inside. If you take from inside, first is mucous layer, second is submucosa, third is muscular cord, and fourth is the serous cord. Serosa. Serosa is the outermost layer, which is always made up of peritoneum. Muscularis is the second layer. Muscularis is formed by smooth muscle fibers arranged in outer longitudinal and inner circular layers. Outer longitudinal and inner circular layers. That is second layer of the wall of the. These are the 4 basic layers. Starting from the esophagus till the inner canal. The GIT consists of 4 basic layers: mucous membrane, submucosa, muscular cord, and serum. From outside to inside, serous cord, muscular cord, submucosa, and mucous cord. Serosa is made up of peritoneum, whereas muscular is made up of muscle fibers, that is smooth muscle fibers, arranged in outer longitudinal inner circular layers. Submucosa. Submucosa contains a loose connective tissue. It contains submucosa is made up of a loose connective tissue and a large venous plexus. Submucosa of duodenum contains duodenal or Brunner's glands. As I already told, duodenum submucosa contains a mucus secreting glands. Those are called as the Brunner's glands. How you can histologically differentiate the side of duodenum from jejunum and ileum? Is it clear? This is, if there is a presence of Brunner's gland in submucosa, straight weight is a slide of duodenum. It is a slide of duodenum. Brunner's glands are present only in the submucosa of the duodenum. So this is the identifying point of a duodenum. There is a presence of Brunner's glands in submucosa. Mucosa composed of a layer of epithelium. Lining epithelium of GIT is lined by which epithelium? Anybody? Yes. Whole GIT is lined by which? What is the lining epithelium of GIT? What is the lining epithelium of GIT? GIT is lined by which epithelium?
Simple squamous epithelium.
It is lined by simple squamous.
Squamous.
Huh?
Columnar. Columnar.
Which columnar?
Ciliated.
Biciliated. Whole GIT is lined by simple columnar epithelium. Yeah, lined by simple columnar epithelium. Okay. Huh? So mucosa consists of three things. One is lining epithelium. Second one is lamina propria. Third one is muscles mucosa. Huh? From inside, first one is lining epithelium. This lining epithelium rests on lamina propria, and the submucosa separate from mucosa by muscles mucosa. This is the structure of the lumen of the small intestine. Inside there is a lumen. This is mesentery. There is the presence of Brunner's gland in the submucosa, and in between the Brunner's villi, there is the presence of gland. Those the depressions are called the crypts of Liberty. And there is the presence of tubular glands. Then comes the mucosa. Same thing you see in histology. The finger-like elevations are called as a villi. The finger-like elevations are called as a villi. These are called as a villi. Same finger-like projections. Those are called as a villi. Okay. So the difference between duodenum is having a Brunner's gland and submucosa, and the slide of small intestine is differentiated from stomach by the presence of villi. Villi are nothing but a finger-like projection into the lumen. Those are called villi. Villi are completely absent in stomach. Villi are very poorly formed or poorly developed in the duodenum. Villi are very much poor in the duodenum, and there is a presence of Brunner's glands. Jejunum contains a very prominent, broad villi. Now, the shape of the villi is like a leaf. How you can differentiate the site of jejunum from the ileum? Okay. Ileum. Jejunum contains a broad, leafy, broad leaf-like villi that is present only in the jejunum, and there is a few lymphoid follicles. Lymphoid follicles are solitary, means single. Solitary. Aggregation lymphoid follicles you see in the ileum. And in between the villi, there is the presence of a depression. Those depressions called as the crypts of Liberty, which contains the glands. Intestinal branches arise from the left side of the, now coming to the blood supply. And one more thing is there is a microvilli. Villi and micro, finger-like projection coming from the lining epithelium is called villi. Same finger-like projection from the lining epithelium. The epithelial free surface of the epithelial cell is having a finger-like projection. Those are called as a microvilli. These are the three things which increase the surface area of the small intestine. Understand? These are the three things which increase the surface area of the small intestine. One is because of length. Second one is because of presence of walls of Carpel. Third is presence of villi. Fourth one is presence of microvilli. And fifth is presence of liver. Now coming to the blood supply of the ileum and jejunum. Ileum and jejunum are supplied by the ileal and jejunal and ileal branches of superior mesenteric artery. These arteries supply the branches of superior mesenteric artery. The branches of superior mesenteric arteries are called as jejunal and ileal branches. These are the branches from the superior mesenteric artery. Intestinal branches arise from the left side of the artery and run in the mesentery to reach the gut. These arteries, the intestinal, jejunal and ileal branches, they arise from the left side of the superior mesenteric artery. Left side of the superior mesenteric artery gives the branches. Those branches are called the jejunal and ileal branches. These intestinal branches arise from the left side of the artery and run in the mesentery. Already you see mesentery. They run in the mesentery. They anastomose one end form a plexus. That is called as the arterial arcade. That is called as the arterial arcade. And further branches, small branches, they arise from this arterial arcade. They end the anastomose and forms a network. That is called as the vasa recta. It is called as the vasa recta. They anastomose one end to form a series of arcades. These branches, they enter into the mesentery through the root and they reach the intestinal border of the intestine. While traversing, they branch an anastomose and forms a network. That network is called as the arcades. Lower part of the ileum is supplied by the ileal branches of ileocholic artery. Remember, ileocholic artery. The lower part of the ileum is supplied by the lowest part of the lowest part of the ileum is supplied by the ileal branches of ileocholic artery. Venous drainage. Veins correspond to branches of superior mesenteric artery and drain into superior mesenteric vein. Now, the duodenum is derived from the sympathetic. That is T6 to T9 and parasympathetic vagus nerves from the celiac and superior mesenteric plexus. Jejunum and ileum nerves are derived from sympathetic and parasympathetic nerves from superior mesenteric plexus. This is the vein carrying the blood to hepatic water vessels. That is lumen of the intestine. So these finger-like elevations are called as the villi. From the villi, again you are seeing the small, minute finger-like projections. Those are called as the microvilli. These are circular folds. These are called as the walls of Kerkring. Walls of Kerkring. And this layer is the muscle cord. This is a muscle cord. Muscle cord is very much thick. It is formed by smooth muscle, which runs into fascia, outer longitudinal and inner circular fascia. Okay, this is the gross structure or histological feature of the intestine. You will not see the lumen in the slide. You will see only cut section of the wall of the intestine, in the duodenum. These are the various layers of the intestine. There is a mucosa, submucosa, muscular layer, and outer this is the serous layer. Plica circularis. Plica circularis or circular folds, also called as the walls of Kerkring, are large valvular flaps projecting into the lumen of the small intestine. They begin in the second part of the duodenum. As you go down towards the ileum, these walls become lesser and they are not prominent. They are very prominent in the second part of the duodenum and part of the ileum. Jejunum. They are very much prominent. As you go towards the distal part of the ileum, these reduces in number. Also, they become less prominent. These are part of the walls of Kerkring. Remember, these are permanent folds formed by the mucosa and submucosa, which project inside the lumen, or called as walls of Kerkring. This is the structure of the villi. As you see, there is the presence of lymphatic vessel and a blood vessel. Intestinal villi are finger-like, as I already told. Intestinal villi are finger-like. Projection of the mucous membrane, just visible to the naked eye. Intestinal villi can be seen. They give the surface of the intestinal mucosa a velvety appearance. Because of the villi, the surface of the intestinal mucosa appears like a velvet appearance. They are large and numerous in the duodenum. Their intestinal villi are very much large and numerous in the duodenum and jejunum, but are smaller and fewer in the ileum. They vary in density from 10 to 40 per square mm and are about 1 to 2 mm long. This is the structure of the villi. Intestinal glands are crypts of Wilberkin. As I told, at the base of the villi, the lining epithelium dips and forms a crypt. Those are called the crypts of Wilberkin. Intestinal glands or crypts of Wilberkin. These are simple tubular glands. So depressions are formed by the simple tubular glands distributed over the entire mucous membrane of the jejunum and ileum. They open by small circular aperture on the surface of the mucous membrane between the villi. They digest enzymes and mucus. Lymphatic follicles. Lymphatic follicles are present. Lymphatic follicles are nothing but as you see the lymph node. There is the aggregation of the lymphocytes. Circular aggregation of the lymphocyte is called lymphatic follicles. These lymphatic follicles may be present singly or it may be present in aggregation. They may present singly, that is called solitary lymphatic follicle, or they may present in 3 to 4 aggregate, means collection, that is called aggregated lymphatic follicles. These lymphatic follicles are more numerous in the ileum. They are very much less. Almost we see single lymphoid follicles in the jejunum and they are absent in the duodenum. Lymphatic follicles are absent in the duodenum. The mucous membrane of small intestine contains two types of lymphates. Solitary means single. Aggregate lymphatic follicles are called as Pierce specks. Those are called as the Pierce specks. Understand? Aggregation of the lymphoid follicle. 3 or 4 lymphoid follicles aggregate and forms a large lymphoid follicle. That is called as the Pierce patches. Pierce patches are ulcerated in typhoid fever, forming wall ulcers with their long axis along the long axis of the body. With typhoid, we see ulcers along the long axis of the long axis of the bowel. Those patches are called as the Pierce patches. Those are called as the Pierce patches. Okay. So this is the cross about the small intestine, which measures 6 meters in length and divided into small duodenum, jejunum, and ileum. Duodenum is the proximal part which is fixed in most dilated part of the small intestine, which is the retroperitoneum, whereas jejunum and ileum are having a maximum mobility because they are suspended by folded peritoneum. That is called as the mesentery. It is called as the mesentery. Understand? So out of this, you may get mesentery as a short term. Mesentery may come as short term, or a second part of the duodenum, or called duodenum come as a long question. Describe the duodenum under the following headings: location, relation, blood supply, and apply. Coming to the apply, duodenum as it is a site to receive time from the stomach. Hence, the first in the radiographs, first part of the duodenum after barium meal, that is the aggregation of the barium sulfate in the first part of the duodenum, and it gives appearance like a cap. So that findings in the X-ray is called as the duodenal cap. Sometimes some X-rays after you are seeing the stomach, over the stomach there is a cap-like structure. That cap-like structure is nothing but first part of the duodenum. So that point radiologically it is called as the duodenal cap. Second is the duodenum is the prone site for duodenal ulcers. Same ulcers already you have seen in the stomach, peptic ulcers. Same ulcers can be present in the duodenum. So duodenum is again site very much prone for the development of duodenal ulcers. Third is the duodenal diverticulus. Duodenum diverticulus. These are the various applied aspects of the duodenum. Okay. Okay. Thank you. Thank you.
Thank you, sir.
Thank you.
Now,
Thank you,
you know
sir.
about the
Thank you,
questions.
sir.
What are the possible long questions in this?
Thank you, sir.
Any doubts? So note down the possible long questions. One is the duodenum, particularly second part of duodenum. This slide we skipped. This is called suspensory muscle of duodenum or ligament of Treach. The duodenal flexion is suspended by a fibromuscular band. From the right curve of the diaphragm, there is a fibromuscular band. This fibromuscular band is called suspensory muscle or suspensory ligament of Treach. This is fibromuscular band which suspends and supports the duodenal flexion. Duodenal flexion is supported and suspended by fibromuscular band. This fibromuscular band extends from the right curve of the diaphragm. It arises from the right curve of diaphragm, close to the right side of the esophagus, passes downwards behind the pancreas, and is attached to posterior surface of the duodenal flexion and third and fourth part of the duodenum. What is suspensor ligament of duodenum? Suspensor ligament of duodenum is the fibromuscular band which extends from the right curve of the diaphragm to the duodenal flexion. It suspends and supports the third and second part of the duodenum. This fibromuscular band is divided into three. Upper one third is the striated muscle, means skeletal muscle. Upper one third of the fibromuscular band is striated muscle. Middle one third is elastic tissue, and lower one third is the smooth muscle. Understand? So this is called as suspensor, which suspend the duodenal flexion from the right curve of the diaphragm. So this is the very important ligament. Because of this, the duodenum is fixed and not having any movement. This is the diagram of a ligament, suspensor ligament of Treach. That is the esophagus. By the side of esophagus, the fibromuscular band attaches from the right curve of diaphragm. It passes below the pancreas and attaches to duodenal flexion and suspends the second and third part of a duodenum. Okay, so this is called as the this is suspensor ligament of a duodenum. Okay, thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Day after tomorrow there is a test. Whatever the portion we have covered, that portion is present. So test is of 50 marks from 11 to 1. You can write the answers in the script and the same thing can be scanned and uploaded to the website. one extruder with the node person, door rest.